All right, thank you, Dr. Cabanas. So, Dr. Myers, we're going to throw it to you now. Can you give us a little bit of background on vaccines and what's so special or what's so different about the new COVID-19 vaccines?
Sure. Thanks very much. And it's nice to virtually visit with some old friends and make some new ones. So thanks again for having me. It's great to be here. Before we get into the details of this slide, I think there's just a couple of observations that we need to make to really, to your point, be in a no spin zone, to be in a place that we're having an honest conversation. Throughout the history of our republic, we have argued about infectious disease. It is nothing new. I think one of the things that people like to think about is that we're having these tremendous debates about public health, and it's never ever happened before. It's happened since the beginning. So that's number one. Number two is there's a lot that has changed since we first entered this pandemic in March. And we could today spend the rest of the day having true debate about when should we have a curfew, if at all? Should we close businesses? Should we close schools? Should we wear masks? And people of good faith with good data could have those debates, and we ought to have those debates because that's who we are. But I want to, as we think about going through the history and how these vaccines work, make one observation. Regardless of political camp, beginning in March, every person in leadership on both sides has agreed the only way out of this is a vaccine. We can argue about opening schools, closing schools, we can argue all that stuff. But the very first thing the Trump administration did is start Operation Warp Speed, which is in large portion while we're here, and we ought to acknowledge that. The very first thing the Biden administration wants to do is make sure 100 million doses of vaccine are delivered in 100 days. So let's, for the moment, if we can, which is hard in the current environment, set aside all of these other debates and realize that leaders of both sides started with vaccine and still are there because that's the only way out of this thing. What's interesting from a historical perspective is Cotton Mather, who was a Puritan minister that preached about souls burning in the fire pits of hell and the Lord holding you over them by the thinnest of a thread, also said you ought to get inoculated. And that was in 1721. And in 1730, 3% of the people that got inoculated died. And unfortunately, in corners of the internet and other places, the notion of switching from inoculation to vaccination hasn't yet been made. And we made that change, as you'll see in a minute, in 1796. But inoculation really is taking a live virus from a sick person and putting it under the skin of somebody else. And the hope is that you get a mild disease in the person that you're extracting the virus from, and the other person's perfectly healthy and they don't die. But that's not a perfect science, and people died from inoculation because they were getting a true live vaccine. Nevertheless, John Adams got it in 1777. George Washington had every soldier inoculated because there were more people dying from smallpox than were dying from the British muskets. And so he made a decision. Thomas Jefferson got his whole family inoculated, but only after his 4-year-old died of smallpox. So throughout our history, we've looked at that. The good news is in 1796, we changed this concept and we no longer inoculate with live active disease. Jenner was able to figure out just by observation that if you're near cowpox, you don't get smallpox. And kind of inferred what we now know to be the way that you can do vaccine, which we'll talk about in a little bit. But look how long it took from 1796, the first vaccine. It was 1980 before the World Health Organization declared this disease completely eradicated. It took a long, long time. We're going to beat that this time. Let's go to the next slide. We're going to talk about a framework about these vaccines, and I just want to give a word of thanks to these 3 physicians that participated in a webinar online and shared a lot of their data. We did not take any of their slides verbatim, although they said we could, but it was their ideas and framework that we've incorporated over the next several slides. So I want to say thank you to them, and I do thank them for sharing their information. So the first thing is, what do vaccines do? And what they do is they allow you to have victory by recognizing the enemy. There's 3 things that come. One is they serve up a protein sequence, otherwise known as an antigen. The best analogy I know there is that that's the flag of the enemy. It allows your body to know the enemy's coming because they know what the flag looks like. It must come in a non-infectious vehicle. We're out of those days of the old smallpox inoculation, but it has to activate the immune system. That's how it works. So people, unfortunately, today say, I got sick from the vaccine. Well, you did feel sick from the vaccine because your immune system was activated, but there was no disease associated with that. And that's the important distinction. When we look at side effects that Jeff will go over in a little bit, if you think about these three things, we're showing a protein, it's a non-infectious vehicle, but it activates your immune system, a lot of the responses from the vaccine become obvious and you can anticipate them. And obviously the goal is don't get sick because your body can respond. Here's just a graphical way of showing the same thing. If we think about those protein sequences as little shapes, and measles has a triangle and chickenpox has a half cross and there's a half circle for flu, if your body's already seen that, then it's already got antibodies ready to respond. However, the green new pathogen there, for the purposes of this illustration, would be the SARS-CoV-2 virus, where the body's never seen that before. And so by the time it mounts an immune response, the infection, or to use the analogy, the invasion, has already occurred and you're already sick. And the goal is to prevent that from happening. This is a graphical illustration of how that worked for cowpox. The surface antigens on cowpox were so similar to the surface antigens for smallpox, and cowpox does not cause human disease. So it meets our criteria for a vaccine. Shows the protein, not infectious, activates the immune system. Since that time, we have done the same thing on variations on the theme for a host of vaccines. Everything that we do up until, we'll see on the next slide, but don't go there yet. But everything that we do has been historically the same thing. We want a non-infectious vehicle to show up a protein sequence to allow the body to know what that looks like so that it's ready to respond to the next. And there's all different ways to do that, but it's all variations back on that old cowpox, smallpox theme. However, next slide, we are now into a very new world. And this way that the Moderna and Pfizer vaccines work is so elegant in its simplicity. Rather than messing around with finding a vehicle to serve up a protein, why don't we just have your body make the protein for us? It's so much cleaner and so much easier. So the scientists, way wicked smart, and I will show you what I know, which is all on this slide, but we know how this works, right? Is we take a messenger RNA and cause the body with its own endogenous protein synthesis mechanism to serve up that protein that we want you to respond to. Then the vaccine is metabolized as normal, goes away. Your body quits making those proteins, but the immune system has already seen them and has responded to them. Absolutely no chance of infection because all we're doing is telling your body to make a certain protein sequence so that your immune system can recognize it. It works great after one. It works really well after this happens twice. And Jeff will go over that in a little bit. But that is what the messenger RNA vaccines are. So the next couple of slides go over some reasons people are hesitant, and rightly so. As Don pointed out at the very beginning, this is a personal and individual decision. So I'm going to go over a little bit of the background here and then talk about what my personal decision is and then talk about the vaccines that are left in the pipeline before I hand it over to Jeff. So number one is it only took 62 days from the time that we had the protein sequence to the messenger RNA vaccine was made. 2 separate labs made it within 12 hours of each other after 62 days. Amazing story. But mid-July, Moderna had theirs in the morning and Pfizer had theirs in the evening, all on the same day. Worldwide attention, we got plenty of volunteers, right? You didn't have to beat the bushes to get volunteers to enroll in the study. You'll see when Jeff does his talk, there's over 70,000 people that have volunteered just for these 2 trials. There's a good prevalence of disease, which is bad when we think about it from a community perspective, but is really good when you're trying to test a vaccine because you want to make sure that somebody's going to get infected so you can tell if the vaccine works or not. And then perhaps most importantly, this last bullet has been kind of taken out of context a little bit, I think. An emergency use authorization is not a full release of a drug. And because of that, you don't have to do the testing on every possible population. So you'll see there were very few people under the age of 18 in these trials, and they just started with the 16 and 17-year-olds. That was purposeful because they wanted to move quickly. pregnant patients, those are to be studied in future trials, immunocompromised, the list goes on, because an EUA is designed to target the population greatest at risk. And we know for right now, the population greatest at risk are likely not in the pregnancy age and certainly not less than 18. And so we move to do that population quickly, and that allows us to move fast. The other thing that comes out a lot is, well, fine with all of that, but the immunity doesn't last anyway. I've seen that in the media. So you get it, and the immunity lasts a few days and goes away. So what good would a vaccine do anyhow? And I get asked this question all the time. So a couple of things, and we can go over this in question and answer in more detail. I don't want to take it all the time here, but just based on antibody trials, it is very clear there have been about 55 million cases of COVID just in the United States since March. That's just a scientific fact. Most of them have been mild or asymptomatic, but there's been 55 million cases. So if you think about a 1 in a million, it's happened 55 times. And the media has had an amazing focus on this disease. So yes, there have been a handful of people that have been reinfected. There's a handful of people that have this very bizarre reaction, but those are the 1 in a millions. The good news is this virus has not recreated human physiology. As it turns out, the immune system still works like it always has. And if you've been exposed to an antigen, you create memory, and well over 90% of the people have persistent immunity. Now, can we tell you that immunity is 10 years long? Of course not, because the disease hasn't been here but since March. But for the time we can measure, there is a persistent immunity, so the vaccine will work. And that's an important piece. And this is a free article for people who want to go into great detail. This will take you into the weeds of how the immune system works. But suffice it to say, 90% of the folks or greater have a persistent immune response, and that's good news.
And that's true for other vaccines as well, right? I mean, that's why we draw titers and give boosters.
Exactly right. And we know the flu is has the least timeline on this, and it also has the most variation. So you have to get one of those every year. But yeah, some of the others you can go longer, right? Same thing. So I agree here with the Wall Street Journal. The people that developed this deserve the Nobel Prize. The rapidity, the scientific rigor, the safety with which they've evaluated this is just unheard of in the history of the world. That's just a fact. And I want to take this 1 minute here to say how I'm making my personal decision. And my personal decision is I love my family, I love my friends, I love my community, and I love my nation. And there's only one way out of this, and it is to get a vaccine. So for me personally, it's not even a question. It is the first minute it's available. And these scientists that did all of this work, the least we can do is roll up our sleeve and use their invention to get out of this mess that we're in. So I think that's an important piece. So let's go into where we are. This is the vaccine tracker from New York Times. There's 40 that are way back still early. There's 7 that have some limited use somewhere around the world. The first 2, which are on the next slide, look at the ones we're going to do a little bit with Jeff, which is Moderna and Pfizer. So I'm not going to spend any time on those. The next 2 are the ones to watch coming over the horizon, and that's Johnson & Johnson and AstraZeneca. These 2 are more of the historical, more common type vaccines where they are serving up this protein sequence on a non-infectious vector. These are not mRNA vaccines. They're taking a little bit longer to develop, and at the moment, while they seem to be very efficacious, they're not as efficacious as the Moderna and Pfizer ones that we've seen so far. The next set I don't think are coming to the United States, but they are approved for places in the world. So in the spirit of transparency, there are places where you can use these vaccines today. I would be very surprised if they came here. And if they did, they would have to go through the exact same FDA process, which none of them have submitted to do. So until they submit to go through that rigorous process, I don't think we should consider them further, but I do think it's important to know there are others that are approved elsewhere in the world, and these are they. So we already talked about what an EUA is. Jeff's going to go into the details of that. It does give you a safety and efficacy profile, some potential side effects and contraindications. The last slide I want to do is the next one, which is the difference between efficacy and effectiveness, because I think from a contextual perspective, that's important to think about as we look at these upcoming data. The first is efficacy means we're in a trial. Does it work in the trial population? And if you think about that, those folks are followed very clearly. They have follow-up calls to come get their vaccines. All of those things are done in a very focused, almost sterile environment, for lack of a better term. And you have to do that to see if the thing actually works. If it's randomized appropriately, then an efficacious trial will also be effective, meaning that we've mirrored the population sufficiently in the trial that it represents the population at large. But effectiveness also has to do with the logistics of this thing. Can we keep it cold enough? Can we get it shipped? Will people come for the second dose? So we know, I think, I'm pretty convinced, I hope you will be too after Jeff talks, we know these vaccines are efficacious. The question now is, can we make them effective? And I think folks in phase 1 have the opportunity to demonstrate how to do that by responsibly showing up not only for the first one, but the second one, and proving that this can be done. So with that, I'll stop and turn it back to you, Don.